Hey, good morning, everybody. Let's do some exercise. Let's see. We gotta do some upside down shoulder push-ups and some pull-ups. Okay. Alright. Let's start with pull-ups, shall we? Yeah, exercise so important. Healthy diet, eating vegetables and fruits, very important. Yeah, those are the key to health, happiness, well-being. All right. Whew. Wow. Wow. I'm hot now. Just one round, like, yeah. Then the upside down shoulder push ups. Okay. Okay. Let's open the window, shall we? Okay. Okay. Wow. Finally, pull ups. Ooh. We take 5 minutes break. Wow. Good exercise, right? How many minutes did it take? 4 minutes. 3, 4 minutes. Okay, that's it. Yeah. Didn't take long. Oh. Okay. Oh, happy Saturday morning. Okay. So, happy Saturday morning. Yeah, I did write this morning about 2 pages for over like 2 hours, I guess. Ow! Because it's Saturday morning, I did not want to write too much. Um, yeah, so I continued to write about Western history, right? So basically, Caucasian Europeans, they're kind of newcomer, newbie, neophyte in science and engineering. Because science and engineering, mathematics, originally is like Middle Eastern thing, right? So, and after the European Caucasians from the north, they invaded Roman Empire. they started to learn this Middle Eastern civilization, Greco-Roman Empire, and from Egypt and everything, Arabs, right? So they started learn science and mathematics, engineering, and after they mastered it, the momentum didn't stop there. They kept now their passion for science carried forward beyond the level of Middle Easterns. And now European Caucasians from 1500 AD and on, even today, they exceeded and keep making. Now 1500 and on, they start making their own science, their own mathematics, European style, American style, okay, engineering. So it's been that's past 500 years, okay, 1500 to 2000. The Caucasians became very powerful in terms of science and engineering. Okay, so yeah, that's what I wrote in 2 pages. Very intense, a lot of citation, mostly Wikipedia. Okay, so yeah, now that that's over now, yeah, I'd like to do some mathematics. Okay, yeah. Why? Asian nerd, just me being Asian. So yeah, mathematics is like originally developed by Middle East brown people, and then Caucasians, right? And then Asians, all right? Yeah, Asians are very good at mathematics nowadays. Science, all right? Okay. Let's do some mathematics. But what we do here is recreational mathematics, nothing serious. All right. Rotational symmetry, right? Or circular symmetry, however you call it. Let me put some more layer. It's cold. Okay. Whew. Cold, cold. Uh, Rotational symmetry. Alright, so that's our side project nowadays. When we want to get away from all that paper writing and stuff, right? Yeah. So we are talking about geometric object, anything like motivated by this diagonal Untitled symbol. I think they may have came from originally not from China but from India or even Tibet. This title symbol, yeah. Because I see this figure in this tantric Buddhism, Tibetan Buddhism. Okay, those Wikipedia or other websites. Okay, about this esoteric, this Tibetan Buddhism. Okay, yeah, I see that figure, title symbol, like three of them, three lobes. looks like this. Okay, it's kind of look like 666. Okay. Okay, and this kind of like three-lobed Tai Chi figure, it also appears in Korea too, in like Korean fan. The color is like red, yellow, and blue. It's very, I guess it came originally from Tibet or India. Okay. And also diduolon, right? Yeah. Okay. So, anyways, so yeah, this is symmetry by 130 degrees. I mean, 120 degrees. So if you rotate 120 degrees, okay, rotate by 240 degrees or 360 degrees, you have exact same figure back. Because that's rotational symmetry concept. There are three ways to do this. 120, 240, 360. This symmetry by 180 degrees. There are two ways to rotate it to come up with the same figure. 180 degrees and 360 degrees. Huh? Right. Well, how about triangle? Yeah, symmetry by 120 degrees. Okay. Yeah. How about rect square? Symmetry by 90 degrees. Yeah? Yeah, if you rotate 90, 180, 270, 360, there are four ways to rotate this to come up with the same figure. Okay? Yeah. So that's rotational symmetry concept. Okay? Right. Now, I wonder this kind of symmetric geometric figure, can we express this in some kind of brand new coordinate system? Okay? I mean, you have polar coordinate, right? Which is really cool. You have R, theta, polar coordinate system. Circle in polar coordinate system is like what? R equal 1. In Cartesian coordinate system, it's like x squared plus y squared is equal to r squared. Okay, that's a circle, right? So yeah, so this circular coordinate system is a lot simpler than Cartesian coordinate system when you want to express circle. Okay, polar coordinate system. Okay, so but we want to find out, invent a brand new coordinate system in order to express geometric figure like square or equilateral triangle. Okay, because to express this in polar coordinate system or Cartesian coordinate system is not easy. Um, not easy at all. So we want to invent a brand new coordinate system to express this kind of like geometric figures. Okay? So let's think about that. Well, as a starter, let's go to Cartesian coordinate system as a starter. Okay, we gotta start somewhere, right? Yeah. Let's start from something that we already know. Cartesian coordinate system. Okay, as a starter. Okay, before we try something new. Okay, and let's say something easy. Square. Okay. By the way, circle is, in terms of rotational symmetry, is it symmetric by what angle? We know triangle symmetry is rotational symmetric, rotationally yes, rotationally symmetric by 120 degrees. Equilateral triangle. Square by 90 degrees. How about circle? How many ways are there if you rotate a circle and to come up with the same figure? So rotation by what angle? Hmm? Hint? Okay. Number of ways, okay, the symmetric ways for triangle, right? Yeah. 360 divided by 120, there are three ways you rotate it. Okay, so for circle, 360 divided by some number, it should go to infinity. Okay, so it kind of gives it away, right? Yeah. It's rotationally symmetric by zero. Why? Because this formula should give us infinity. So, and this has to be zero. Because a little bit counterintuitive, right? But it kind of makes sense. Because you have square, 360 divided by what, 94, right? And you have octagon and you have pentagon, okay? So this denominator becomes smaller and smaller and smaller. So when it becomes circle, okay, which is like infinite agon, you have pentagon, octagon, then infinity agon, that's circle, okay? So it makes sense that this becomes zero. Okay? Am I going too fast? Don't worry, it's not important, okay? So, but if you don't understand what I'm saying, if you want to understand, watch previous episode again and this episode again, okay? We are just doing this for fun. Okay? We may have later on formalize it if we have time, if we want to. Okay. Now, yeah, let's move on. Okay. Yeah, we'll take 5 minutes break. All right. So, okay, it's not that important, but if you want to understand this, yeah, watch the previous episodes and this episode again. Then you'll get it. Why? Because it's not a very difficult concept. Okay. Okay, we'll take 5 minutes. All right. Okay. Uh, Okay. Well, I guess we can approach this in a couple of different ways, but one way to look at it might be vectors. All right. So, um, in Cartesian coordinate system, okay, when you read angle, you read counterclockwise from the x-axis, horizontal axis. Okay, so you have 45 degrees here. Here you have negative 45 degrees. Okay? So, and you have vector originating from the point of origin to this line. Okay? Right? Yeah, you can kind of partition the square into four sections where you have this range of angles. Here you have from 45 degrees to 135 degrees. Okay? In that range, all these vectors. Okay? Uh, I guess it's kind of hybrid between polar coordinate and Cartesian coordinate, right? You know, this label is really bothering me on these short pants underneath that I'm wearing. I'm not sure if I can just rip it out. No. Maybe I cut it with scissors. Whatever. Okay. Okay. Let's take 5 minutes break. Okay, I gotta write something. Okay, so what I'm gonna write? Yeah, the propagation of science. Yeah, from Middle Easterns, Caucasians, then Asians. Okay, so let me write that. Okay, so it's kind of important. So okay, so what now? I guess we can do this, right? Like something like we're being very informal. Okay, so after all, it's just Saturday morning, so minus 45 degrees, 45 degrees. You have equation x is equal to 1. From 45 to 135, your equation y is equal to 1. 135 to add 90, okay, so 225. X is equal to minus 1. From 225 to add 90, 315, right? Y equal minus 1. Yeah, instead of calling it minus 45, we do it as 315, okay, so. So why do we call it 360 degrees? Have you ever thought about that? It's because, I give you a minute. Why whole circle, why do we call it 360 degrees? I give you a minute, okay? Because I wanted to start drinking, okay? So I give you 2 minutes, okay? So let me drink. Yeah. Uh, the question is, why do we call whole circle 160 degrees? Why not some other degrees? Where does 160 come from? Okay, that's the question. I give you like 2 minutes, okay? So, so in this paper, I kind of express this pro-Asian activism a little bit, okay? So, yeah, Asians are excelling in science and mathematics, okay? So, Asian pride. Yeah, I think it's okay for me to do that, right? Because I'm Asian. Let's, as an Asian American, let's give some due respect, tribute to my fellow Asian Americans, okay? Yeah, I think that's cool. All right, the reason is we have day and night. We have 4 seasons. Well, some parts of the world, okay? So let's say from summer equinox to the next summer equinox, the longest day of the year, right? You have about 365 days, right? So that's where it came from, 160 degrees. Roughly 165, okay? So it's the, in a given year, you have 165 days, okay? So that's where it came from, okay? So most likely, okay? So here we can use Boolean hybrid, right? Boolean hybrid, okay? So we are talking about vector, okay? So it's kind of like it's Cartesian and polar coordinate hybrid too, right? We're talking about vector, all right? And a vector have an angle, all right? So, uh, okay? So, square. is defined as, so in vector analysis, okay, a dot is correspond to a vector, okay, right? Any geometric figure is composed of dots, okay, because eventually maybe it's possible to come up with the equation that express this diagonal. Okay. Any geometric figure is just collection of just individual dots, right? And in vector analysis, a dot is a vector. Why? You just connect from origin to that dot, then you have a vector. I think that's the way to go. Okay, so okay. Now I'm getting cold again. I have to turn on the heater. Turn it on, turn it back off. Oh boy. Yeah, I'm very sensitive about temperature and moisture. Ah, you're so sensitive. You're so sensitive. Yeah. All right, let's go ahead and do this, okay? Why? Because we don't have to get it right the first time, okay? We can always modify, refine, tweak a little bit, okay? So let's say that kind of looks weird, huh? We'll do negative 45. The 315, that's bigger than 45. That's why it kind of looks strange, right? Yeah. Yeah, this Iverson bracket, well, we rather call it Boolean hybrid. Okay, so multiply by, should we do plus here? I think so. Why? If theta, it can be only one angle. Okay, so, and because these four sets are mutually exclusive, and so they are complete, they are partitions of this whole angle. Okay, so theta will only belong to one of these ranges. Okay, so yeah, it's safe to do so. Okay, so instead of like, let's use radian system because that's a lot simpler, smaller number radian system. Okay, so quarter over pi. Okay, so pi in Greek letter. Okay, not pizza pie, okay, there's 360 degrees, but pi is 180 degrees in mathematics, okay? A lot simpler, right? Yeah, just add 90 degrees, which is like pi over 2, which is 2 pi over 4, okay? So a lot easier. Yeah, radian system is very handy. Okay, so that's that. Whew. Mm. Okay, very good, right? Kinda. If you ask me, this is the best I can do. How to define a square with an equation, right? Yeah, it end up being Boolean hybrid, which is fine. That's legit. I got some bracket. But I'm kind of wondering, yeah, the next step will be this, okay? Any geometric figure, we want to express it with some one equation, okay, single equation. What if there is this square and there's another square, bigger square, they kind of geometric figure, like carpet pattern, okay? Carpet, mosaic, whatever, okay? Let's try to express that. Okay, we'll take 5 minutes break, and you have square and bigger square, okay? That two squares. Let's express it in mathematics, okay? Now, in mathematical language, okay? So, all right, we'll take 5 minutes break, okay? So, how interesting. Because in this tantric Buddhism, there are a lot of like squares and geometric figures, very recursive structure, okay? Yeah, Indians are they're very good at mathematics, so all right. We'll take 5 minutes, okay? All right. Very good, very good. Okay. We're gonna have to grab a new whiteboard. Well, let's take a picture of this. Yeah, I put in the social media or something. Let's take a picture of this baby. Okay. Let's grab a new whiteboard. Yeah, the origin of humanology, yeah, it's something I've been working on for more than 2 decades, right? Yeah, try to come up with alternative to psychology. So I've been studying like Western science and Eastern philosophy, right? And also in Korea, there's this concept called ki. Okay, it means energy. Okay, so yeah, Korean language, Korean culture, 기, 기 살다, 기 죽다, 뭐 기를 제압한다. It means energy, human energy. Okay, so copium came from that Korean culture. 기, it means energy. Okay, my Korean name is Lee Gi. That ki is different. That does not mean energy. It means foundation. Hun means constitution. So my parents gave me very ambitious name, the foundation of constitution. Okay, so that's what my first name means, given name. Okay, yeah, beautiful name, and very grateful to my parents. Okay, so yeah, yeah, parents are ambitious about their children, right? Yeah, so, yeah, that's cool. Anyway, so in traditionally function, right? You function, right? Yeah, you have x, y, 0, right? One-to-one correspondence. That's traditional definition of function. Okay. So circle is not one-to-one correspondence because you have one x and you have two y's. X, y1, y2. So that's not traditional definition of function. Okay. But they expanded the definition of function to occur one day geometric figures like this. Okay. Now, where's my black pen? I love black pen. It's thick black pen. We have whiteboard here. Okay, so we're not talking about ultra intellectualism. Okay, we just talk about whiteboard and pens. Okay, so no politics. Okay, we're just doing mathematics. Okay, two squares. Okay, let's pretend this is a square. Okay, so 1 and 2. So independent variable here is theta angle. Okay, so uh, it's not x. It's a hybrid coordinate system where we use r and theta in polar coordinate system, and also we will also use x and y. Okay, this hybrid coordinate system. Okay, that's the coordinate system we just invented. Okay, good. Given angle theta, you have 2 points, two vectors. Okay, Yeah, so that's our next task. So it's Boolean hybrid, but it's slightly more than that. Okay, we may have to use the concept. We have to borrow concept from set theory, union. Okay, set union. All right, so okay, so this double square, right? We call it ds. Okay, we come up with the equation later. Okay, but for this guy, you have between angle. Okay, we gotta fill in the blank. Okay, so I give you like 5 minutes. Okay, because I don't know that yet. It has to be with some union. All right, so okay, so I want to drink. Okay, why don't you figure this out? Okay, so if you want to, you don't have to. All right, we'll do it together. I want to drink. Saturday morning vodka, baby. Oh, I'm sorry, not you. You are not a baby. Okay, so I am. Yay! Look at me, I'm a baby. I'm just drinker, smoker, midnight talker. Okay, joker. Yeah, there's a song about that. Yeah, Steve Miller Band. Okay, I'm no saint. I'm just joker, smoker, drinker, midnight talker. Space Cowboy. Yeah, Steve Miller Band. Okay. Yeah, maybe I sing that song. Whatever. Okay. Hmm. I'll just call Union. Okay. Yeah. Yeah. It's very sloppy mathematics. But mathematics is a language as long as we understand what this means. Yeah, I think this is the one that should go in there. All right. As long as what we understand what it means, because language is somewhat arbitrary. APPLE, apple. Okay. Why do we spell this fruit, delicious fruit, APPLE, apple? We don't have to, and that's how it is. In English, yeah, it's APPLE, but in Spanish, it's manzana, MANZANA. In Korean, it's sagwa. So different language, okay. It's just arbitrary social contract. That's what language is. Grammar, okay. Vocabulary, semantics, syntax, whatever. So yeah, mathematical language is a language. It's a promise, social contract, agreement between amongst speak of this mathematical language, mathematicians, all right? So as long as we understand what it is, it's understandable, it kind of makes sense, then that's good, okay? Yeah. It's hybrid between what? Boolean algebra, and you have set theory, you have Cartesian coordinate system, you have polar coordinate system, okay? And vector concept. We're just putting it all together. Okay? It's cross metaphysical cross pollination. All right? Okay. I think we are kind of ready to mathematically express diduolon. Let's think about it, okay? Let's jump ahead. Equation for diduolon, okay? Taichi symbol, all right? So yeah, most likely section, four sections, like 0 to 90 degrees, 180 degrees, 270 degrees, okay? And then uh yeah, it may get messy a little bit, okay? Maybe not. We want to find equation that is as simple as possible, right? So circle, yeah. Okay. Let's say this small circle, okay, and we'll move it like this to the right, okay, and let's say radius is 1, okay. So the small circle put centered at origin is r is equal to 1, right? But if you shift to the right by 1/2, how do you express that? Kind of polar coordinate, Cartesian coordinate hybrid. Yeah. I mean, because here you have half circle, right? Maybe we should just use Cartesian system, like this guy is like y is equal to what? Square root of x squared. right? Yeah. But it shifted by 1/2. Hey, yeah, I don't like this. Uh, and this half circle down there, let's say this is y1, y2 minus. Okay. I mean, complex equation, yeah, it's kind of beautiful. It looks like a tank, machinery, right? There's some beauty of complexity in some mathematics. Okay, yeah, I guess that's fine. Hmm. We just do that, okay? Yeah. Because in polar coordinate system, you can not quite shift things, right? Yeah, you have to use Cartesian coordinate to shift, make shift, right? It's ugly. I mean, not ugly. There's some beauty in complexity, right? Yeah. Cosmos. I just do that, okay? We'll take 5 to 10 minutes break and we'll express didual with a single mathematical equation. I think we are ready, okay? Yeah, okay. All right, let's take 5 minutes, okay? How interesting. We'll take 5 minutes. Well, maybe 10 minutes. Let's take a picture of this baby, okay? It's okay looking, I guess. Uh, Happy Saturday morning. Afternoon. Yeah. Okay, you're gonna have to replace this whiteboard with another one. Okay, so whiteboard hunting. We use this guy. Okay, the only non-magnetic old school whiteboard, the oldest one I have here in my house. All right. Yeah. We use this guy. All right. I cannot erase this thing. You don't forget it. We use this guy instead. Hopefully it's amenable to erasing. I have this magnetic eraser. Good, good. Very good. It has this magnetic suction power, pressure. Okay, so good invention, right? Yeah. I'm not crying. It's something out in my eye. Left corner of my left eye. Okay. Let's go ahead and do this, okay? Yeah. Yeah, it's afternoon. Yeah, I didn't realize that. Okay. Happy Saturday afternoon. Okay, so we'll do this. All right. Semicircle and full circle. All right. To make it easy. All right. Let's say this is 4. Okay. You have 2. So that the radius of smaller circle is 1. Okay. All right. So this semicircle equation is this. Okay. We call it y1. Okay. No, it's not necessary. My bad. All right, so it doesn't have to be 2 and 4. It can be just 1 and 2. Okay, so precision eraser. Okay, so this guy, semicircle in fourth quadrant, right? Okay, and this guy, semicircle in third quadrant, right? Quadrant 1, 2, 3, 4. Okay, all we are doing is just some middle school mathematics or high school, whatever. Okay, so this guy is y1. Okay, this guy is y2. The full circle, this guy is y3. Okay, some elementary mathematics in middle school. Mathematics education, very important, right? But y2 minus square root 1 minus, the radius is 1. Okay, so okay, y3 we just call it r is equal to 2. Okay, so y, because it's not it didn't shift from this point of origin 0. Okay, so is it blasphemous? I put 0 in the second quadrant. Doesn't matter. Alright, so yeah, we are hybridizing Cartesian coordinate and polar coordinate. Okay, so for simplicity sake. And it's over. Okay? Diduolon, right? Diduolon equation in mathematical language. I mean, to express in fine art painting with pen and pencil and paper is easy, right? But to express in mathematical language, it's more involved. Okay, so diduolon is this. Eh, yeah, sure. Yeah, yeah. 2 pi, which is 0. Okay, that's that. Y1, Y2, Y3 is that. Okay, so you plug that in. Yeah, it become too bulky. Okay, so, but for consistency, yeah, you can put this as what? Plus minus. I just, for the sake of consistency, okay, so plus minus square root of 4 minus x squared, okay, so whatever, okay, you plug that in, then you have this equation, mathematical language expression of the ideal, and we got it, okay, so very good. All it takes is some high school, middle school algebra, analytic algebra, okay, and some inventiveness, like we are using this Boolean hybrid, Iverson bracket, Boolean algebra, and some coordination between Cartesian algebra, Cartesian geometry, and polar coordinate system. Okay, we got it. All right. Good. Congratulations. We got it. Okay, so we express diagonal in mathematical language. Let's take a picture of this baby, okay? And we'll take 5 minutes break. Then I'll tell you more about history of humanology, this particular version of humanology, okay? So, let's take a picture of this baby. Oh, alright. This is a very historic moment, okay? Whew. Good. We finally got it. Mathematical expression of diagonal. Touch symbol, okay? Wow. Hmm. Yeah, I'm satisfied with this. All right. Yeah. Language translation, the language of fine art, just painting, right? Pen and pencil. Okay, and the language of, yeah, I kind of learn how to stop this flickering of this different lighting. I have to just pick one spot in this laptop computer. They stop flicking around, right? Lightness, brightness, focusing. Okay. Yeah, so we got it. Okay, yeah. Diagonal in fine art, very simple. Painting, pencil and paper, whiteboard and black pen, right? But in mathematical language, it's a little bit more involved, right? Yeah. Does this have any use? I think so. When computer programmers program things, okay, yeah, they have to use mathematics, okay. Yeah, the pixels, location, okay, yeah, it's about memorization, right? Yeah, you can enlarge it by whatever algorithm, computer programming, okay. But if we have this mathematical expression, then we are empowering computer programmers to do more things. Okay, so that's something very cool. Okay, yeah. So yeah, it's mathematical language which can be very easily translated to computer program language. Okay, so we are making some contribution here. Okay, okay, yeah. Because computer science, computer programming is based upon mathematics, logic, like Boolean logic, Boolean algebra, binary like one and zero. Okay, others. Okay, so let's take 5 minutes. Okay, yeah. Good. We got it. We capture diaduolon in mathematical language, mathematical net. Let's say diaduolon of fish in the sea. We cast the net of mathematical language and we got it. Okay. We harnessed this wild animal, diaduolon, Taiji symbol. We expressed it in mathematical language. So we are witnessing history in the making. Okay, this is something very significant. Why? Taiji symbol, diaduolon, is from east. Mathematics, west. East and West meet together finally. It's very historic moment. Right? So, congratulations. Pat on the back, okay? Yeah. Let's congratulate ourselves. We came a long way. We'll take 5 minutes break and maybe I sing some songs, okay? So how about Fat Boy Slim? Came a long way, baby. Something. Yeah, I'm the baby, okay? Yeah. You're not a baby. You're my parents, okay? So metaphysical parents, okay? Praise you. So basically what we came up with here is this, okay, it's a hybrid coordinate system, Cartesian, polar, Boolean, hybrid coordinate system. That's what we are doing here, okay. You have Boolean hybrid, Iverson bracket, okay. And you have Cartesian coordinate, you have polar coordinate, okay, so we are mixing it all together, okay. Boolean, Cartesian, polar, hybrid coordinate system. That's what we came up with here, okay. We are inventing brand new mathematics here. Okay, so yeah, welcome to Humanology, alright. We do that stuff, okay, so yeah. For future generation, we can give them some homework assignment, okay. So idle hands is becomes devil's playground, okay. Book of Proverbs, King Solomon. Okay. Yeah, homework assignment. Okay. Nice and easy. You have triangle. Okay. Express this triangle in terms of Cartesian, polar, Boolean, hybrid coordinate system. Cartesian, Boolean, polar, hybrid coordinate system. Okay. Some Eastern European languages, okay, like you have Polish, you have Russian, okay, a lot of these consonants, like Zdravstvuyte, okay, so very exotic, beautiful languages, okay, so because I'm studying Russian, okay. How do you say here? Zdis, okay. Yeah, in Korean, there's some similarity between Korean language and Russian, okay. We have the consonant, right? Roughly correspond to the English E. Okay. So здравствуйте, yeah. This it means here, now. Yeah, сейчас. I'm learning Russian language. Okay, beautiful language. So how would you express triangle in this Cartesian, Boolean, polar, hybrid coordinate system? Okay. 스브 프흐 스스. Okay? Yeah. Whatever. 크브 프흐 크스. Okay? Yeah. I looks like some kind of occult religious symbol. Okay. You have cross, you have triangle. No, it's not that, okay? It's not Jesus Christ, it's just Cartesian system, okay? Rune Descartes. X, Y, 0, okay? And triangle. Yeah, find out this coordinate here. Yeah, the equation of this straight line, y is equal to what? Minus x plus something. Y is equal to x minus something. This is like y is equal to minus something, right? Yeah. Then you partition three different angles, right? Minus what? 120 degrees to 90 degrees and 90 degrees to 240 degrees. Okay. Minus 60 degrees to 90 degrees. 90 degrees to, you know what? Let's do this, okay? Yeah. So it's for fun. Yeah, knowledge rotation, that's lifelong happiness. Key to lifelong happiness. Okay. We get bored, right? We rotation, crop rotation, nomadic tribe, okay? In a circle, okay? Like animals. Grazing animals like Alaska moose or caribous. Yeah, centaur. Yeah, though. caribous, right? We'll take 5 minutes, okay? And then we'll go ahead and do this. We have to grab another whiteboard, okay? So, okay, we'll take 5 minutes. Ooh, it's getting cold. Okay, we're gonna have to find brand new whiteboard. Eh, no problem. Who's this guy? I have no idea what this is about, right? Take a picture and erase it, right? Yeah, I have no idea what we did here. Okay, so long time ago, right? Yeah, no clue what it all meant. What it used to mean, okay. It's all tape recorded, okay. Published in Humanology series in Google YouTube, so it's all there somewhere, right? Probably like 5 months ago. Yeah. Okay, we come up with the equation of a triangle, right? Yeah, language, okay, as long as we make ourselves understood by other people, as long as we understand other people, it's all cool, okay? APPLE, how did it come about? We don't know. Doesn't matter. So yeah, this language recognition, this artificial intelligence, like neural network, okay, it's based on pattern recognition. Okay, we don't care why people spell it APPLE, but this pattern. People pronounce it like apple, Apfel in German, right? Or apple in English. Okay, yeah, pattern recognition. We don't know, we don't care how it came about. This kind of spelling APPLE, but there's some recognized pattern. Okay, so voice recognition, artificial intelligence based on neural network. Okay, yeah, we just want to find a pattern, common pattern. All right, then we are cool. That's what language is about. Okay, pattern recognition. We don't care the logic, rationale behind spelling of APPLE. We don't know why. We don't care. All right, just look at the result. That's it. Okay, so language, right? Okay, let's go ahead and do this. Yeah. All right. All right. Equilateral triangle. Okay, so okay. Now that we have so many pens, let's take advantage of it. Okay, so what's this angle? 30 degrees. Pi over 6 minus. Okay, so 7 pi over 6. Okay, so 30 degrees. Okay. Okay. Yeah, in this instance, it's easier to use just degree system as opposed to radian system. Okay, so it's too confusing. Okay, so minus 30 degrees Okay, and 120 degrees, right? Yeah. Minus 30 degrees is like what? 330 degrees, right? Yeah. Oh, this is not 120. It's like 180 plus 30, so 210 degrees. Okay, so yeah, yeah, okay, whatever. We stick with radian system. It's too confusing. Okay, so yeah, I'm a drunken mathematician. Okay, I'm amateur. Yeah, so 30 degrees minus pi over 6, and this is pi plus pi over 6, so 7 over 6 pi. Okay, yeah, this is kind of tricky, right? Yeah, we want to find coordinate for this guy, and that guy. Okay, this guy. Yeah, it's a little bit tricky. Geometry problem. Okay, so a little bit tricky. Okay, so for the sake of easiness, okay, we'll call this guy one. All right, from here to there, one, one. All right. E. Then what's this guy then? Well, I don't know. It's been such a long time. Middle school, high school algebra, geometry problem. Okay, so it's been a long time. But the key to lifelong happiness, lifetime happiness, circle, knowledge circle, knowledge rotation. Okay, so okay. Oh boy. Well, let's draw a circle, right, with radius one. Okay. Euclidean geometry. Okay. Greek guy, Mr. Euclid. I don't know how to say Mr. in Greek. Let me look that up. Okay, so I have Google Translator app in my cell phone. So how do you say Mr. in Greek? Curious. 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 I didn't know that. Curious, like Curious. Okay. Curious. Curious. Euclid. Yeah, curious. Yeah, Mr. Euclid. He was curious about mathematics. Okay. Curious Euclid. Mr. Euclid. Okay. So, how interesting. I don't know. All right. That's your equilateral triangle. Okay. So, what's the length of this equilateral triangle of this radius one circle? Okay. So, you're 120 degrees, right? So, yeah, we have to use this generalized Pythagorean theorem. Okay. Okay. What's the formula? It's like something like that. Is it plus or minus? Well, let's plug in 90 degrees. Cosine 90, well, that's theta. Let's plug in theta being 180 degrees or 0 degrees. Okay. Okay, so you have B, C, and A. Theta, right? When cosine is 0, theta is 0, that cosine 0 is 1. Okay, so when theta is 0, A is equal to 0, right? Yeah, B minus C, right? Yeah. When theta is 0, A is equal to C minus B or B minus C. Okay, okay. Hmm? Good enough. Right. When theta is 180 degrees, pi, cosine pi is minus 1, so that's like B plus 1. Okay, okay. Hmm. Because cosine pi is minus 1, so it's B plus C squared. Okay, so, okay. That makes sense. Okay. When cosine is 120 degrees, that's like, my goodness, it's been such a long time. Trigonometry, alright. Hey, hey. Cosine curve, okay. So you have 90, 180. Yeah, sine, cosine, trigonometry, very symmetric, okay, so 90 plus 30, okay, that's like, right? Sine curve, cosine curve, very symmetric. It's circular, right? It's cosine 30. Ah, oh boy. Like square root of 3 or something. Ah, trigonometry, long time ago. 25 years ago, okay? Oh boy. You're 60 degrees, okay? Something like that, right? How about 30 degrees? Hey. 60 degrees is like 1 square root of 3 and 2, right? 30 degrees, that's complement of 90 degrees, okay? So here you have 30 degrees, right? So you have 1 square root of 3 and 2, okay? So divide by 2, okay? Square root of 3 over 2 and 1 over 2, okay? Okay. So what's cosine of 30 degrees? Square root of 3 over 2, okay? So minus square root of 3 over 2, okay, okay, okay. Okay. Which is about, yeah, square root of 3, there's a 1.7 something, okay? So divide by 2 is like, uh, 0.85, something like that, okay? Okay. And to plug into that formula, oh my goodness. Ay, oh boy. We are trying to find this length of this guy. Okay, that's A. All right. BNC 1. Okay, so 1 plus 1 minus 2 times this guy. Okay, so yeah, we'll take 5 minutes break. Okay. We're having intellectual entertainment, right? Some high school mathematics, right? Yeah. Geometry. Mm, yeah. We'll take 5 minutes and continue on this. Okay. We get to the bottom of this thing. Okay. Excuse me. Yeah, we'll take 5 minutes break. Oh, mathematics makes me sneeze. Let's snap how old it is, okay? It's Saturday afternoon, okay? Yeah, all this mathematical mumbo jumbo, geometrical nonsense or sense, science, whatever, okay? Yeah, we can leave it to tomorrow or future generation. It's just simple geometric problem, very beautiful. I I'm having some difficulty, okay? Because my mathematics is not that good. All right, yeah, given time, if you can calculate all that stuff, okay, yeah. Plug in 1, square root of 3 over 2, okay. Calculate all that stuff, find out this coordinate of these three dots, whatever, okay, and then three partitions, okay, some Boolean hybrid, okay, yeah, we'll leave it to future generation, okay, so let's put this behind us, all right. Maybe we'll do this, continue on this tonight, okay, not now though. We're gonna take a break. It's Saturday. It's weekend, okay, so I'm gonna take a picture though, okay? Yeah. Let's take a picture. That's beautiful. Geometry. Very beautiful. Yeah. I learned good geometry. Korean middle school, high school, 학교, 학원, public school, private school after public school, okay. So, and my mother in Seoul, South Korea, she was very good at geometry when she was in high school. Okay. She majored in fine art in college. I'm sure it helped. Okay. Yeah. So yeah, geometry is beautiful. Right? Euclid, Euclidean geometry, Archimedes, pyramid, Egyptians, Arabs, Greeks, Romans, right? Yeah, yeah. Fantastic. We'll pick that up later, okay? So the moral of the story is, yeah, crop rotation, nomadic tribes, okay, we rotate animals, just like animals, right? In Russia, there are these Asiatic Mongolian tribes called Yakuts. Okay, they harnessed, tamed reindeers. So they are nomadic tribes in Russia. Okay, they're very well protected because they tamed and ride on top of these caribous, reindeers. Okay, okay, and they're nomadic tribes. Okay, so yeah, lifelong happiness is about knowledge rotation. Okay. Yeah, we learn foreign language and mathematics like clock, circle of life. Like 4 seasons, day and night. Okay, foreign language study, mathematics, physics, biology, engineering, politics, philosophy. Then mathematics again, physics, biology, foreign language, history, politics, rotation. Okay, knowledge rotation. That's the key to lifelong happiness. Or dancing, martial arts, singing, music, painting, fine art, whatever, sculpture, okay? Yeah. No drugs, no, no crimes, no money, power, fame, no SCX, but we can still be happy. No obesity, okay? Yeah, we're doing martial arts, dancing, singing. If you're good at it, yeah, musical instruments too, okay? So we are never bored, okay? So knowledge, education, that's key to lifelong happiness, prevention of crime, prevention of drug addiction. Okay, so yeah, we study some religions. We love religions. So yeah, that's the bottom line. Okay. Yeah, I watched like 2 decades ago this documentary, The Bridge, Golden Gate Bridge in San Francisco. It's about people who jump off the bridge, committing suicide. Okay. Then I came up with a theory. What if these people who are about to commit suicide, jumping off the bridge, what if there's suddenly a tiger, lion, or grizzly bear chasing after them? Would they jump off the bridge? Or would they just hunker down, sit there, or would they run away? I give you a minute. Okay? Yeah, people who are about to jump off the San Francisco Golden Gate Bridge to commit suicide, when they see grizzly bear chasing after them or tiger, lion chasing after them, would they run away or would they jump off the bridge? I give you 1 minute, okay? If you want to think about it, okay? Then I tell you what I think. Yeah. Maybe 2 minutes. I give you 2 minutes. Huh? Thought experiment. Humanological thought experiment. Yeah, Mr. Albert Einstein, yeah, he did contribute to this popularization of thought experiment. We admit that. Okay. He's cool. Although he was wrong in relativity theories. But yeah, he made some contributions. We admit that. So if you ask me, my guess is that they would start to run away from chasing grizzly bears, lions, tigers, or burglars, murderers, rapists, whatever, okay? Because there's this thrill, challenge of outrunning rapists, murderer, bear, lion, tiger. They would enjoy that, okay? They would have given them new meaning of life, survivalism, right? I don't think they would have jumped off the bridge if they were chasing tigers. I doubt it, okay? So yeah, it's the challenge that we encounter in lives that give us first meaning of life or excitement of life. Challenges, problems. Maybe that's why God created all these problems so that we engage ourselves in solving these problems of homelessness, crimes, poverty, racism, sexism, misogyny, whatever. Okay? Maybe that's why God created the devil, Satan, 666, Antichrist, the beast, whatever. Okay? Because he want us to be busy. Like good bosses, superiors, employers. They want to keep us occupied on our living. They want us to work. God, the boss, creator, the controller. Hi, Almighty God. Okay. If you subscribe to some religions, okay, yeah, he or she or they wanna keep us occupied, busy, keep us busy, like good old bosses, superiors, employers want us to be. Okay, so yeah. So he created all these problems, so unnecessary crimes, homelessness, immorality, unethical things, right? So that we solve those problems, keep us occupied, keep us busy, right? Yeah, problem solving, challenges, obstacles, overcoming, surmounting. Okay, yeah. Oh, it looks like insurmountable, but Mr. Jesus said Hey, I'm Mr. Jesus. If you have this mustard seed amount, this small modicum of faith, you can move the mountain, okay? In time. Alright? Yeah. So keep the faith, babies, earthlings. He said something like that. I'm paraphrasing, okay? He said something like that, okay? Yeah. I think people commit suicide. Some people commit suicide because they are bored, right? Yeah. We're talking about Marilyn Monroe, Miss Marilyn Monroe, Miss Elvis Presley, Mr. Elvis Presley, Mr. James Dean. Okay, if they're bored, right? Yeah. Drug overdose, adrenaline rush of this race car, whatever. Okay, I think it's just a case of boredom, right? Yeah. They're just bored, but they didn't have benefit of education. We do. Okay. And we want to spread the words of this Holy Spirit, right? Wealth of knowledge. In humanology, we encompass all the knowledges out there, like mathematics, physics, philosophy, religion, politics, economics, anything, okay? Yeah. Foreign languages, right? Yeah. So we are always interested, excited about learning something new. We learn from other people, books, websites. No problem. We never get bored because we got we are beneficiaries of mentors, parents, siblings, friends, teachers, professors, colleagues, bosses, subordinates, superiors. Okay, we learn from them. Okay, they initiated, they introduced us to something new, like mathematics, physics, biology, foreign languages, even some random strangers in social media, websites, television, movie, whatever, books, okay? Propagation of good ideologies like Holy Spirit. Huh? Yeah. So that's what we do here, okay? So we never get bored. Look at that mathematics problem, geometry that I learned. I was good at it when I was in middle school, high school, in South Korea, okay? But that's like 25 years ago. Nowadays, yeah, I'm kind of rusty, clunky, okay? But we'll get to the bottom of that problem, okay? We'll calculate that stuff. But we had enough for this episode. We'll tackle on that. We'll get back to that like this evening or maybe tomorrow, Sunday, okay? It's beautiful, challenging problem, okay? So we're not bored. I had to sneeze out of that. Why? It was too much for Saturday afternoon, okay? So we will get to the bottom of that. Geometry, Euclidean geometry, Greek tradition. Because it's challenging, we love challenges. It's like metaphysical hiking up the hill, going up the mountain, right? Brain muscle, okay? So we'll do that, okay? It's beautiful, it's very educational. Euclidean geometry by the Greeks, right? Curiosity, yeah. Oh, curious, curious. Curious, Euclid, Mr. Euclid. Okay. Greek language. I've never to Greece. Okay, but I've only seen Greece in the pictures, movies, TVs. I have some friends, even in Alaska or some other states. Okay, who are descendants of Greeks, and I'm like, Oh, you are descendants of Greeks. Okay, I'm a huge fan of this. Greek philosophy, Greek geometry. You have very good ancestors. Okay, so I met some Greeks, Greek Americans. Okay, several. Right. Yeah. I'm a huge admirer, a huge fan of your ancestors, Greeks. They went to Greece, okay, because I don't have that much money or time, okay. But I'm a huge admirer of Greek mythology, philosophy, like Plato, Aristotle, Socrates, and Euclid, okay, Greek mathematics, Greek philosophy. I'm a huge fan. Because I met some Greek Americans, okay, whose ancestors were Greeks. I'm like, oh, I am your number one fan, okay, Greek philosophy, culture, history. Thank you. Okay, yeah. Beautiful language. Like alphabet, epsilon, and sigma, Greek letters, exotic, so beautiful. Mathematical language, right? Yeah, you have theta, sigma, psi, or theta, psi. Very beautiful ancient Greek letters. Okay, so beautiful. Yeah, Russian Cyrillic alphabet is based on Greek alphabet. Okay, Cyrillic alphabet. Okay, so yeah, Greek Orthodox, right? Russian tradition. Okay. Yeah, in Alaska we have some Greeks, Greek Americans, Russian Orthodox Alaskans. We have Ukrainian Alaskans. Okay. Yeah, so Russian language, Cyrillic alphabet based on Greek alphabet. Okay. Beautiful language. Okay. Beautiful letters. This calligraphy and type font. This so beautiful. Like Sigma, Theta, Psi, Psi. Okay. That's very beautiful language. Okay. Greek letters. Greek Americans. I met about five of them. Okay. In Alaska. Okay. Over places. Fantastic people. Okay. So Russians, Ukrainians, great cooks. Okay. They know how to cook these vegetables and yeah, they're really cool. Okay. So yeah, I'm studying Russian language. Okay. Greek language, Latin language, like Italian, Romance languages. Yeah, I want to learn. Okay. It's in my list of things that I want to learn. You'll never run out of languages to foreign languages to learn, right? Mathematics, physics, okay. But some of them are garbages, right? Like special general relativity theories. Absolute garbage, trash, falsehood, falsity, okay. Yeah, but there's some good mathematics, good physics, okay. Yeah. Okay, I start cooking my brunch. I didn't eat anything, right? So yeah, let me start cooking my dinner. I mean, not dinner yet. Brunch, breakfast, and lunch. Okay. What's in the menu? I don't know. Maybe ramen noodle, vegetable, salmon soup in one plastic container. Yeah. So something healthy, okay? Yeah. Okay. Merry Christmas, Happy Hanukkah, okay? Happy holidays, and yeah, happy holidays, okay? Thank you. I'll see you later this evening. Thank you. Bye.